All right, and we're back. Okay, so here's the deal. What I'm going to do is I'm going to walk you through 4 or 5 problems right now, but I don't want to just walk you through the problems. What I want to do is I want to set up the problem, talk to you about it, and have you give it a try. You'll try it for 3, 4, 5 minutes, give it your best. Hopefully you come to the right answer, or even if you get stuck, we'll see, you can stop there, and we'll pause the video for the time that you're working, and then once you guys are done, we'll go ahead and unpause the video, and hopefully you work it out the same way I do. Okay, so I'm going to start. I'm on page 117. In case you want to look at the actual problem, I'll try to explain all of it, so all the pertinent information will be right here on the board. But either way, I'm looking at number 24 on page 117, and it says, in a class of 25 students, the average score is 84. Okay, so in a class of 25, the average score among everybody is 84. However, in that class, there are 6 students that receive 100. There's 6 students who have 100% average, okay? And there's 3 students that have a 60%. Or a 60. And the question is, what is the average score of the remaining students? And so that's our job to figure out. Okay, we're going to still try to walk through the basic 4 steps. So we're going to identify the variable. We're going to translate from words to algebra. We're going to set up a model, and we're going to solve it. And so what I want you to do is I want you to go ahead and try to go through those steps right now. We'll pause the video for as long as we need to, and then we can walk through it together. All right, here we go. Step number 1, identify the variable. That's always pretty much the easiest one because it's almost always the question. And just right here, it said, hey, what is the average of the remaining students? So I'm going to use the letter A for average of remaining students, okay? Average for remaining students. Okay, step 2, now I got to translate, all right? And so here is the average for the remaining students. We know that that's A. And then we think the average of all students, and that's 84, okay? And then we know total students in the situation, and these are all really basic things. The total number of students is 25. And so if you look at it and you think about the total number of points, if there's 25 students and they together average an 84, then you could multiply 25 times 84 and you'd get what, 2,100. And 2,100 is basically the total points. You know, it's 2,100 that when divided by 25, you get that average of 84. And so that's, I'm looking at, that's the total number of points. Okay. But then there are, we got to look at the, remaining points. Because we realize that the remaining points, we've got to take care of these guys right here, these ones that we're taking out. And so that'll be 2,100 minus 6 100s and minus 3 60s. And we go, okay, so 2,100 minus 600 would get us down to 1,500. And then 3 times 60 is 180. So 1,500 minus 180 is 1,320. So that's the remaining points after we take out the people who are on the top and the people who are on the bottom, okay? And so then, and I guess we could do also remaining students because we need to know how many students are left in this situation. And the number of remaining students after we take, so it's going to be 25 minus 6 minus 3 gives us 16, okay? And at this point, the problem becomes really simple. You go, okay, so now all I have to do is set up the model, and that would be the remaining points divided by the remaining students is going to give me the average. And so then let's switch that over to numbers and solve. Remaining points, 1,320. Remaining students, 16, okay? Which is then going to equal A, my average. And if I plug that into a calculator, I get, I believe, 82.5%. So after I take out those 6 students who have the 100 and those 3 students have the 60, the remaining average is 82.5. And hopefully that's what you got. I don't know that maybe you identified all of the different parts as I did, but again, I just want to encourage you to, some of the problems, a problem like this is a relatively basic problem. And so there's going to be a lot of students, especially students in this class, who can say, you know what, just give me a calculator and I can, figure it out. I can kind of force it. But man, the more we walk through it with this ideology, I'm telling you, the better off you're going to get. So that way, even on the complicated ones, you can set up the model and it'll work. All right, let's try the next one. Next one is number 30 on the same page, page 117. And the problem says a woman earns 15% more than her husband. Together, they make $69,875 per year. What is the husband's annual salary? Okay, and so then that's the variable. That's step one, variable. You go, we could say X is the husband's salary, and it says annual salary. Okay, and then we got to go to translating. And so husband's salary is X. And then the question is, what's the wife's salary based off the husband's salary being X? Well, it says she makes 15% more. And this is where some people go wrong. They say 0.15X. And that's not right. That's 15% of his salary, but that's not 15% more than his salary. And so we need his salary as well as that 15%. And so there's two ways to do this. You can either... I'm just realizing I never asked you to pause the video. I got rolling right into this. So hopefully, hopefully you either pause the video or you're going to pause it right now, realizing I never took a breath. And so we can pause the video right now and you can try to figure out the rest. Okay, we're back. All right, so there's two ways. You can either say 15% of his salary plus his salary, plus X. Or another way of writing that would be to say 115% of his salary. Those two things are synonymous. Those two things are equal, okay? It doesn't matter which way you go. The wife's salary is 115% of the husband's salary, or the wife's salary is 15% of the husband's salary plus his salary, okay? And so then we set up the model. And what's the model? The model is the wife's salary plus the husband's salary is equal to the total. And I guess that's the only thing I didn't list in the translating, and I probably should have put that there of what the total was. But we saw that I've already got that written, and that's probably why I didn't rewrite it. The total is $69,875. Okay, so now let's go ahead and fill in all the blanks. The wife's salary is 1.15X, the husband's salary is X, and the total is $69,875. When I combine these, I get 2.15X is equal to $69,875. And all I have to do at this point is divide both sides by that 2.15. And let's see. All right, sorry, I had a calculator just slightly out of reach for me. 69,875 divided by 2.15, I get that his salary is 32,500. Okay? And so then that was the answer to the question. The answer to the question was his salary is 32,500. Now, we could go back and figure out what her salary was as well. If this question was worded a little bit better, I think that that's what they should have asked, is what's each person's salary. But they just asked about his, and so that's what it is. All right, the next problem. We're going to look at number 35. Number 35 is going to seem a little bit challenging. It's on the next page, page 118. I'll try to remember to take a breath and let us pause the video on this one. But it says that there's this person that has some change. A change purse contains... All right. I don't know what that sounded like, but there's just an announcement called down to me, so hopefully that didn't interrupt too badly. But here we go. We've got a change purse that contains the same number of each coins. It's got pennies, nickels, and dimes in it, and the total is $1.44. And our job is to figure out how many of each coin is there. But the good news is we know it's all the same amount. So go ahead and think about how you would do this. Identify the variable, translate it, set up your model, and solve. You can pause the video right here. All right, let's give this a go. Okay, number one, I'm going to say X is the number of each coin. And I can use that because I don't need to know the number of pennies and the number of nickels and the number of dimes because it's the same, okay? And then so step two, let's go ahead and do some translating. The number of each coin excuse me, is X. And let's see here. Then we got to start thinking about the value. The value of the pennies is going to be 0.01 times X. And the value of the nickels is going to be 0.05 times the X. And the value of the dimes is 0.10 times X. Okay, that's the actual monetary value of each one of those coins. And we put in X because X represents the number of coins, how many of them. So if we got 8 pennies, we know it's 8 times 0.01, it gives us 8 cents or $0.08 dollars. All right, so that's a pretty straightforward, simple thing. And we know that the total is $1.44. At this point, we can go ahead and set up our model. And we say, okay, so what's our model? Our model is the value of the pennies plus the value of the nickels plus the value of the dimes all must equal the total. And if the value of the pennies is 0.01x and the value of the nickels is 0.05x and the value of the dimes is 0.10x and the total is 1.44, we can add these up. 0.01 plus 0.05 is 0.06 plus 0.1 is going to be 0.16x equals 1.44. And at this point, you just divide. Divide both sides by the 0.16, and you get x is equal to 9. And what does that mean? Well, that means that there are 9 pennies and 9 nickels and 9 dimes. And that makes sense, because if you had 9 cents plus 9 nickels would be 45 cents, plus 9 dimes would be 90 cents, you would get $1.44. So that answer works and makes sense. Okay, now that we've tried at least one with money, I want you to, hopefully this next one will flow a little bit easier. Maybe people were really locked up on how to start this one, but this next one involves the exact same situation, except this time they're going to do nickels, dimes, and quarters, and they're going to put a little variation about how many of each, okay, but it's still very solvable. So the next one we're going to try is number 36, okay? Number 36, it starts it out by saying, hey, there's a total of $3. And the two things you need to know are there is twice as many dimes as quarters and 5 more nickels than dimes. And then the question is, how many of each type of coin? Now, so this one has a little bit of weird variation. A lot of people want to pick 3 variables and go, well, I need a variable for nickels, variable for dimes, and a variable for quarters. But when you look at this statement right here, twice as many dimes as quarters, and you look at this statement, 5 more nickels than dimes, the thing that I hear twice is dimes. And so I realized that I can talk about my number of quarters in relationship of dimes. I can talk about my number of nickels in relationship of dimes. And I can obviously talk about how many dimes in relationship of dimes. And so now that I'm trying to help you out to at least get you started on this one, because I know it's more challenging, go ahead and see if you can identify the variable, translate, set up a model, and solve. And you can pause the video here and we'll walk through it in just a second. All right, here we go. So hopefully you got from that hint. The big hint is that D, the number of dimes, is the variable. Okay? And 2, you can say, well, number of dimes is D. Now people still mess this up, especially this second line. Hang on one sec. All right, I'm sorry about the interruption there. Man, this has been all sorts of full of interruptions. Okay, the number of dimes, D. Now, the second sentence is where people really screw this up. And that is because they can't figure out which one to multiply by 2. It says twice as many dimes as quarters. And so everybody always wants to say, okay, 2 times D equals how many quarters I got. But all you have to do is think about this. The part that helps with translation is think about reality. If I told you I had twice as many dimes as quarters, and I had 10 dimes, and I had twice as many dimes as quarters, then you would know I only have 5 quarters, okay? Twice as many dimes as I do quarters, okay? I have twice as many dimes. So look, I've got 10 dimes and only 5 quarters. So that means quarters is the smaller number, meaning I would actually have to multiply quarters by 2 to set them equal to each other. And that's what I need to do. Or in this case, since I'm talking about everything in terms of dimes, I need to talk about cutting the number of dimes in half. So the number of quarters is 1/2 the number of dimes. And then it says there are 5 more nickels than dimes. And so think about that. If I had 10 dimes, how many nickels do I have? 5 more nickels than I do dimes. So that's going to be D plus 5. Okay? So the number of nickels is D plus 5. Awesome. Okay, here we go. So now, and then we know that the total is $3. There we go. Fantastic. Okay. Awesome. And so now we look at this, let's set up the model. I guess the one thing I didn't do is I didn't talk about the value of each. And so that's where maybe I'll just kind of slip that in real quick. We know that the value of dimes is going to be equal to 0.1 times D. We know that the value of quarters is going to be 0.25 times 1/2 D. And we know that the value of nickels is going to be 0.05 times D plus 5. Okay, and so now my model, and I'm sorry that I didn't have that illustrated there earlier. So now my model is I add up the values. And I say the value of dimes plus the value of quarters plus the value of nickels all must equal the total. And that's pretty simple at this point, okay? So the value of dimes, 0.1 D, plus the value of quarters, 0.25 times 1/2 D. And plus the value of nickels, 0.05 D plus 5 equals $3. Okay? Now let's just go down the list. A fourth of a half is an eighth, which is 0.125. So I got 0.1 D plus 0.125 D plus 0.05 D plus 0.05 times 5 is 0.25. The only one that doesn't have a D on it. Okay? I can combine all the rest of them, and it should be what? I'll have 0.275 D plus 0.25 equals $3. Subtract the 0.25 from both sides, and I get 0.275 D is equal to 2.75. And we go, well, clearly, when I divide both sides by 0.275, this becomes really easy. You can see that D must be 10. And so then, now you're not done, but now you at least have answered how many dimes you have. And now you got to take that and plug it back in and say, okay, so if I know how many dimes I've got, I know I have 10 dimes. So D is equal to 10. But then go answer your question. How many, and isn't that funny? I actually picked that by accident. I'm sorry. So how many quarters do I have? Well, how many quarters I have? I have 5. And how many nickels do I have? Well, nickels, I must have 15. You should be able to answer that for each one. Okay? All right, last one that I'm going to ask you about is number 44. Number 44 is a problem where it shows some kind of poster that has a printed area and then also has a blank strip of uniform width around the edges. The perimeter of the poster is 1.5 times the perimeter of the printed area. Okay, 1.5 times the printed area. The perimeter of the printed area, okay? This isn't about area, it's about perimeter. And so it says, what is the width of the blank strip? And that's our job to figure out. Okay, so we can see that the printed area, and this is 44 on page 118, we can see the printed area is 140 by 100, and it has this uniform blank strip that we're labeling X all the way around. Okay? Go ahead and see if you can figure this one out by identifying the variable, translating it into algebra, setting up a model, and solving it. So we can pause the video right here. All right, here's what I'm going to do. X is clearly the width of the blank strip. 2, we're going to translate. And so the width is X. And then what we can do here is we can say that the perimeter of the printed area is going to be 2 times 140 plus 2 times 100, which equals 480. Okay? 280 plus 200 more would be 480. Yeah. Okay. And the perimeter of the poster, now we got to add x on both sides of the 140. And we got to add x on both sides of the 100. So we get 2 times 2x plus 140 plus 2 times 2x plus 100. That's the perimeter of the poster, the entire poster. Okay? And then we know the relationship also is that the perimeter of the poster is 1.5 times the perimeter of the printed area, 480. All right? And so then our model, we go, this is easy. Okay, we can say that the perimeter of the poster is equal to 1.5 times the perimeter of the printed area. Okay? And we go ahead and set that up. The perimeter of the poster, which we know to be 2 times 2x plus 140 plus 2 times 2x plus 100 equals 1.5 times 480. And now we just solve. I mean, this is really straightforward. We can distribute here and get 4x plus 280 plus 4x plus 200 equals 1.5 times 480 is 720. So then we have 8x plus 480 equals 720. Subtract the 480 from both sides, and we're left with 8x is equal to 240. Divide by 8, and we get x is equal to 30. So it is, as this says, 30. Just want to double check that seems right. That seems a little bit big. I'm surprised. That seems bigger than I would have expected. But it looks like all the math is right. So we're saying that the uniform blank strip is 30 centimeters wide. All right, we're going to go ahead and pass out a practice quiz right now. Try your best on that, and we'll give it a go and try to see if we can do any of these type of problems tomorrow. All right, I'll talk to you later.